the cosmic demise of a water balloon. Alright, picture this. We're floating 1,000 kilometers above the Earth, and we've got a water balloon. What happens if we just let it go?
You might think it's a simple case of instant freeze, a satisfying explosion, or maybe even a dramatic vaporization. But trust me, the reality is far more interesting.
It's a complex dance of physics, a delicate interplay of factors that leads to a surprisingly dramatic and somewhat anticlimactic result. First, let's set the stage. At 1,000 kilometers, we're practically in space. The atmosphere is incredibly thin, a near vacuum. This means negligible air resistance. And surprisingly, minimal aerodynamic heating, so no fiery re-entry for our little blue friend. The two main players in this cosmic drama are temperature and pressure, or rather, the extreme lack thereof. Space is cold, really, really cold. We're talking around negative 270 degrees Celsius or negative 454 degrees Fahrenheit.
That's just a few degrees above absolute zero,
The point where all atomic motion theoretically stops. Brr.
and then there's the pressure, or rather, the absence of it.
The near vacuum of space has a profound effect on our water balloon. Okay, so the water is going to freeze, right? Absolutely. The extreme cold will see to that pretty quickly. But here's where things get interesting. This isn't your average freezer burn type of freezing.
In the vacuum of space,
Water doesn't just freeze and stay frozen. It undergoes something called sublimation. Sublimation is when a solid transforms directly into a gas, skipping the liquid phase entirely. Think of it as the water's express lane to vaporhood. So, the frozen water on the surface of our balloon starts to turn directly into water vapor, which then floats away into the void. This sublimation process leads to a rapid loss of mass. Our water balloon is literally disappearing before our eyes, molecule by molecule. The water vapor expands into the vacuum, creating a tiny, fleeting cloud around the balloon. Meanwhile, the balloon itself, made of rubber, is getting hammered by the extreme cold. It becomes brittle, losing its elasticity. It's likely to crack or even shatter, like a frozen twig snapping in winter. As the water sublimates, the balloon loses its structural integrity. It's like the air slowly leaking out of a tire. So what's the final verdict? Does our water balloon explode in a glorious icy spectacle? Not quite. It freezes, yes, but then it rapidly sublimates, turning into a ghostly cloud of water vapor. The balloon itself disintegrates, likely cracking or shattering into tiny pieces. And the contents, well, they disperse into the vast emptiness of space. What's left? We have fragments of the balloon material and a cloud of water molecules. These remnants spread out into space, carried by the faintest of forces. They form a fleeting, ephemeral cloud, a cosmic ghost of the water balloon that once was. This cloud consists of tiny icy particles, slowly drifting further and further apart. The fate of our water balloon is a surprisingly complex process. It's not just a simple freeze and shatter. It's dominated by sublimation, the direct transition from solid ice to water vapor, driven by the vacuum of space. The end result? Disintegration and dispersion, a quiet farewell in the grand theater of the cosmos.